So today we're going to be finding this integral, and we're going to be putting it in the form of ln of the square root of a over b, where a and b are positive integers. Now in this case, we need to think about the integration technique we're going to use, and here, because it looks like a question where we can use partial fractions, right, because this is 1 divided by x multiplied by 1 plus x squared, we can sort of break it down into our constituent partial fractions. So we'll write it out as the following. Now from here we can multiply both sides by this denominator. And what we can recognize is we can start equating coefficients, because we know that on the left hand side here, we know that there is a coefficient of 0 for x squared, so we can imagine a imaginary 0x squared plus 0x plus 1, right? So we can start equating the coefficients, so let's do that really quickly. Now, we are given the value of a, because if we equate coefficients, we recognize that 1 equals the constant over here, which is also equal to a. So we can substitute that into our original equation, and we can find the value of b is equal to -1. We can now substitute this back into our integral. And we can recognize the integral of 1 over x is equal to ln of x. We're going to take this integral over to this side over here, and we can use u substitution in this case. If we let u equal x squared plus 1, we let du on dx equal 2x, we can then recognize that du on 2x is equal to dx, which means we can substitute this back into our integral. We're going to call this integral I naught, and I naught now equals, which we can then cancel out the 2x's, and then we get our integral over here, which is now half ln of u, which we can substitute back into here, because we know that u equals x squared plus 1. We know that half ln of x squared plus 1 is the answer for this integral over here. And then we put in our boundaries, and then from here it's pretty simple. We can substitute in our boundaries and get our final answer.